Hi and Assalamualaikum everyone. We are from Group B1G. Now we'll present the group case study and our group used the data set number 7. For this case study, we need to analyze the survey data collected from the passengers of the light rail transit LRT system to identify factors influencing passenger satisfaction. Next, using the range of statistical methods, including the t-test, confidence interval, ANOVA, and a non-parametric test, the study investigates whether the satisfaction level differ across demographic groups such as gender, age, education level, and employment status, as well as the key service features like capacity, emergency information, and timelines. The objective is to provide insights that can support data-driven decisions for improving the LRT service. Now we will move on to the question 1. Assalamualaikum and good morning everyone. My name is Nurfati Nabila. Now I would like to present my finding for question number 1, which explore the age distribution of LRT passengers based on the survey data. For part A, I construct a normal probability plot using the recorded ages. The data points closely follow a straight diagonal line with only a minor deviation at the ends. This pattern suggests that the age distribution is approximately normal, which validates the use of parametric methods such as t-test in subsequent analysis, which we can use for the question number 1B. Next, part B. I perform an independent sample t-test to determine if there is a significant difference in the mean age between female and male of the LRT passengers. Next, I find the sample size, mean standard deviation, and variance of both gender. Thirdly, I compute the t-value and the result is 0.96 and the degree of freedom is approximately 67. This gives us the p-value around 0.34. Since the value is greater than the common significant level of 0.05, we fail to reject the null hypothesis, which in the simpler terms, there's no statistically significant difference in the average age between the genders in the sample. Moving on to the next part of the question, which is part C, I calculate the probability that the mean sample is greater than the 26 years using the central limit theorem and the appropriate standard error. I found the probability to be approximately 92.65%, indicating that it's highly likely for the sample mean is to exceed 26 years. Lastly, for part D, I calculate the probability that the sample means falls between 23 and 25 years. The result was only about 0.11%, meaning it is extremely unlikely for the sample mean to fall within that narrow range given the population distribution of the sample size. Now I will pass to the next presenter.
Hi, my name is Nur Aisha Safia. So I will talk about question 2. So for the question 2A, we constructed a 19% confidence interval to estimate the difference in the proportion of certified passenger between the two facility quality items of the LRT service. So out of the 120 passengers, 63 were satisfied with the facility quality 1, which is given a sample proportion of the 0.5 to 5, while for the facility quality 2, 73 passengers were satisfied, which is resulting in a proportion of the 0.6083. So the difference in the sample proportion we got was negative 0.0833. Then the standard error we got was calculated as the 0.067, and using a Z value of the 1.645 for the 90% confidence, the margin error was 0.1048. Therefore, the confidence interval for the difference in the proportion was from the negative 0.188 to 0.022. Since this interval includes 0, we conclude that there is no significant difference in passenger satisfaction between the two facility quality items at the 19% confidence interval. So for question 2B, in this hypothesis test, we aim to determine if the female passenger have a higher mean satisfaction score than the male passenger at the 5% significant level. So the null hypothesis states that the mean satisfaction of the female passenger is less than or equal to the male passengers, while the alternative hypothesis states that the female satisfaction is higher than the male. So this was tested using a one-tailed independent t-test. So the female group has the 82 respondents with the mean 3.5915 and the standard deviation of 0.8094, while the male group had 38 respondents with a mean of the 3.7237 and the standard deviation 0.5415. So the calculated standard error we got was the 0.1253. Then the t statistic we found to be the negative 1.0551 with the degree of freedom taken as the 37. So the critical t-value of this one tail test at the 5% level is 1.699. Since the compute that t statistic is less than the critical value, we fail to reject the null hypothesis. Therefore, we conclude that there is no evidence to show that the female passenger have significant higher satisfaction than the male passenger at the 5% level of the significant. So that's all for my part.
Hi, my name is Akmal Sapwan and I contributed to question 3A, hypothesis testings with related samples. I'll be presenting the results of a paired samples t-test conducted on the two variables that I chose, which are SS4 and FQ1. So these two variables were selected because they come from the same group of participants. Since each participant provided both scores, this allows us to analyze the differences between pairs, which fits the paired samples t-test. For hypotheses, or non-hypotheses assume that there is no difference between the two means. The alternative hypotheses suggest that a significant difference does exist. For paired t-tests to be valid, certain assumptions must be made. The data must come from matched pairs, the difference scores should be roughly normally distributed, and the data must be on an interval or ratio scale. Moving on to test statistics and calculations. Now, all of the calculations were done in Excel worksheet. I found the mean of differences, standard deviation, sample size, t-statistics, and p-value, and put it in the table. We found that the t-statistic is 1.1740 and the p-value is 0.2427. Since our p-value is greater than 0.05, we fail to reject the null hypothesis. This means that there is no statistically significant difference between the SS4 and FQ1 scores.
Hi everyone, my name is Muhammad Hakim and I will be explaining the results of a one-way ANOVA test for FQ1. FQ1 measures the satisfaction with seating capacity in the train. We wanted to see if the mean satisfaction scores FQ1 are different depending on employment status. The null hypothesis is that all employment groups have equal mean FQ1 scores, while the alternative hypothesis is that at least one group is different. As shown in the bar chart, the employed group has the highest average score, while the self-employed group has the lowest. Students and unemployed groups fall in between. This ANOVA helps us check if these values differences are statistically significant. The full results, including the F value and P value, are discussed in the analysis section. After doing the calculation, the result of the one-way ANOVA test are F statistic was 1.9462 with a P value of 0.126. Since the P value 0.126 is more than 0.05 or 5%, we fail to reject the null hypothesis. This means there is no statistically significant difference in seating satisfaction or FQ1 across employment groups at the 5% significance level.
I will present the T-squared test of independence that we conclude to examine whether there is a relationship between gender and private transport usage. For this test, we selected two categorical variables, which is gender and private transport usage, which was recorded as either yes or no. We set up our hypothesis as follows. The first one is the null hypothesis, states that gender and private transport usage are independent, meaning there is no association. And the second one is the alternative hypothesis, suggests that gender and private transport usage are independent, meaning there is an association. And this one is the following result. So now let's interpret what this means in the next slide. Looking at our result, we can now interpret the findings. Since our p-value is 0.3810 is greater than the significance level of 0.05, we fail to reject the null hypothesis. This means that there is no statistically significant association between gender and private transport usage among LRT passengers. Now, I will present the result of the man-Whitney test, which we use to determine whether there is a significant difference in satisfaction levels between male and female LRT passengers. We choose this test because satisfaction scores are ordinal and may not follow a normal distribution, making the man-Whitney test appropriate for comparing two independence groups. And for the hypothesis, the first one is the null hypothesis. There is no significant difference in the distribution of satisfaction scores between male and females. And the second one is the alternative hypothesis. There is a significant difference in the distribution of satisfaction scores between male and females. And this is the result. From the test result, we observe that the p-value is 0.7328, which is clearly greater than our chosen significance level 0.05. Therefore, we fail to reject the null hypothesis. This means there is no statistically significant difference in satisfaction scores between male and female LRT passengers. In conclusion, the man-Whitney test showed that gender does not significantly affect passenger satisfaction, which is U equals to 1479.5 and p-value is 0.7328. So we can say that males and females reported similar satisfaction levels when using the LRT service.
Hi, my name is Rani Zaini. I will handle question 4C. For question 4C, we conducted a Kruskal-Wallis test to explore whether education level affect a passenger's satisfaction with LRT service. We selected education level as our independent variable, which consists of three distinct groups: high school graduate or below, bachelor's degree, graduate or above. The dependent variable is the PS1 score, which reflects a measure of satisfaction based on the passenger perceptions. So, we use the Kruskal-Wallis test because the PS1 scores are not normally distributed, making this non-parametric test a suitable alternative to ANOVA. The Kruskal-Wallis hash test is a rank-based non-parametric test that determines whether samples originate from the same distribution. It is an alternative to one-way ANOVA when the assumption of normality or homogeneity or variance are not met. This is the statistical formula where N is total number of observation, K is number of groups, R is sum of ranks for group, and I sample size for group. Result is test statistical is 0.197, degrees of freedom is 2, critical value at alpha is 0.05, which is 5.991, p-value is more than 0.05. Since hash is less than critical value and p is more than 0.05, we fail to reject the null hypothesis. The analysis reveals that there is no statistical significant difference in PS1 scores among the three education levels. This implies that education level does not appear to influence the satisfaction with LRT service, at least in terms of PS1. The distribution of the satisfaction scores are comparable across the education categories. After analyzing dataset 7 using different statistical tests, we found that factors such as age, gender, education level, and job status do not have a big impact on how people perceive or feel satisfied with the LRT service. All the results from tests like t-test, ANOVA, chi-square, and non-parametric tests showed no significant difference between the groups. In short, the findings suggest that demographic background does not really influence how satisfied people are or how they rate this LRT service in this sample.